Ladies and gentlemen, thank you for joining me here today, and welcome to Logging in a DevOps World. One piece of advice right away, this is a PSFramework presentation. I very subtly hinted at that. All the techniques implemented as shown today are part of that PowerShell module, and only that PowerShell module. However, even if you can't take a dependency on something like that, most of the techniques and considerations should be applicable to your own solutions or other logging mechanisms you might have available. So let's talk about logging. It's what I would actually like to do. Unfortunately, however, it sends me to have to bring terrible news. I bring news of a murder. Poor Bello was found dead on a street, roasted as if struck by lightning, for that had been a cloudless day. And no, that was not in Seattle. And in fact, he was not alone. Bello was not the only such victim. Again and again, innocent, cuddly, and fluffy creatures are being murdered. You have to help me to put an end to this act of mass puppycide. Stop using right log. Or right host. Use right piece of message instead. All right, we're going to go live into the action because, quite frankly, we've seen enough PowerPoints for today. Unfortunately, we will be returning to a few of the PowerPoint things because concepts like the architecture will need a few diagrams, so we'll be returning to that. We'll be talking about what makes this solution particularly suitable for DevOps. And I'm going to do like multilingual localization issues that have been recently plaguing me. I've got customers that want their code in English and German, and how to manage that, probably especially if you also factor logging into the thing. And that's the main part, really, the main meat of the thing. How can you extend it to, well, your own personal needs? How is it not just another write log that logs to a file, but how to customize it to what suits you? All right. And off we go. Thank you very much, VS Code. I love when I do this. Did I ever mention that it's like my constant curse, to the point that I have updated for every single presentation? I've got a setup script that updates my VS Code profile so I can recover from something like that. So I've got everything still going, still ready. So is the font size all right that way? Or excellent. Okay. So let's just execute a right piece of message. We wrote a message. It went somewhere. Wherever that went. Actually, by default, it replaces write verbose. So it was written to the verbose stream. Who of you likes to use -verbose when he tries to figure out why something went wrong in a script, so he enables extra verbose logging? Yeah, that is one of the greatest anti-pattern that I've so far noticed in PowerShell, and I've been a victim myself. I was junior admin, writing my first few scripts, doing things. And I was debugging a script, running it again and again with -verbose, and something was breaking. Red stuff was written to the screen. And at some point, the customer was calling me, Fred? Yes, Mr. Meyer? Why do you keep rebooting our terminals? So we kind of like to get back to working. The thing is, when you use the -verbose to figure out what's happening here, it means that something already broke. So in order to figure out what went wrong, you have to go back and break it again to see what happened. Now the problem with this was the script was rebooting a server. So when I ran it again with -verbose, I got a completely different error picture because suddenly I could not connect to it anymore. So I was trying to troubleshoot WinRM problems, which suddenly, for some mysterious reason, went away until I tried it again, and then they would suddenly be again there. What the hell? So what I really miss about write verbose is forensics. I want to know what message was written even if I did not see it on screen. So the first log, really, that I really care about, and it's very important to me, is actually not to file, not to a service, but to memory. Everything is available. All the information, the messages, the command that wrote it, and what line it was written, and level variables. So if we try this again, it was the same, just when you specify the variable. So what levels are there out there? We have, very surprisingly, a host level, which is totally going to bright the screen by default. We have warning, and we have a very entertaining debug. Who of you likes to use debug or write debug in your code, or uses -debug to debug something? Oh, one person. Thank you. That makes, by the way, 2, at least since I implemented this. I had at PSConf EU last year, I had a chat with Jeffrey Snow on this, and his comment on interrupting on every single write debug when you use -debug. He said when they decided this, he must have been on vacation. And now, please, VS Code, don't die on me. Thank you. So we have all nice message levels that matched from one command to another, do we? Well, not quite. We've got a numeric value from 1 through 9 for the levels, and some of them just happen to match to what you're used to. Actually, host is level 2, variables is 5, and debug is 8. So you can scale it, and there's a configuration setting to automatically make something less visible the more nested the command is. So if you've got like 5 nestings deep, you can remove the innermost verbose messages because they're not really relevant to be flooding your screen. So by default, ranges 1 through 3 will be printed on screen, and 4 through 6 will be in the verbose channel, but all of them will be part of the logging. No matter the level, in the log files, they'll still be available. So there's a configuration setting for everything. So if you prefer to see things more visible on the screen, you just update the setting to a larger number. And now, even somewhat verbose messages are visible to you. Now, somewhat verbose is good for the strong and silent type. If you've got a girlfriend that is a bit more on the chatty nature, very verbose might be just the thing for you. All right, let's set it back to the default value because I really don't want it spamming on me during the entire presentation. Now, if you're saying, hey, I want to replace write host with something, and the first thing I got back from a friend is, that's all nice and well, but where are my colors? Well, they're here. HTML-style text. You can use explicit console colors for this. PSFramework is compatible until PowerShell version 3, so I can't just use the new color escapes. So I'm still supporting console colors. And EM and ZAP are emphasis and subtle. Those can be configured by the user. So if you change your color scheme and the module developer just forces certain colors on you, it's just not always compatible. And with this, you can make sure you're not haunting your users. No, 7 was not supposed to. All right, but we've got something in memory. We've got some customization, some user convenience. What about a log file? By default, it will write to app data, to a folder, and quite a few messages by now. But if you look at the timestamps, except that I've been rather spammy during the conference run-up, they don't go that far into the past. Automatic debug log with automatic log rotate. They stay by default for 7 days. Both the retention and the location of where they're going can be configured by the configuration system. I won't be digging into that today because it would be like another presentation. which is why I have an entire another presentation on Thursday on how to manage it. Suffice to say, you can deploy those settings by group policy. You can persist it permanently on your machine. You can deploy it using JSON configurations file in your CI/CD workflow. It's flexible. So what is in one of those? Let's grab the latest one, drag it into VS Code. And we've got a CSV file with a lot of information, like the computer, the user, timestamps, messages, and everything else you might be needing to debug things, including file and line number, what command, and the entire call stack. That's at the end. Which, since I was running mostly interactively, is not all that entertaining, but there's a lot of it. OK. Let's do some crashing on us by logging an exception and writing it to the log. If you use the error record object itself will be part of the logs. This is when you look into the logs, the XML files come in. These are fully serialized error record XMLs. You can retrieve them and get the actual exception data. It also saves you the trouble of having to pass through the error message to the message you're writing. It will automatically be appended unless you disable it. There's a parameter to disable it. All right. It's also, of course, part in memory. In memory, you get the full access to the entire object. For troubleshooting purposes, rather helpful. OK, now, this is all nice, but it requires for you to, well, replace all your other message commands so far with write PSF message. And if you've got lots of code and not all of it in your own control, this might not be really feasible for you. For example, imagine you're using the module of an entire different team, and they're telling you, yeah, right, we are so totally going to use that system. Tell us the next one. So for those rather hesitant people, you can create an alias for the command you want to redirect and point it at write PSF message proxy. And write PSF message proxy detects what command it was called by and automatically picks the right message level for it. So if we're going to now send a write host message, it is automatically redirected and sent to the logging system, which incidentally also turns up here. Or, of course, in the log files. All right. Unfortunately, with that, the god of PowerPoint has us again. All right. Now, what makes the entire thing suitable for DevOps? The first thing I really need to know about it is, like, what do I expect from something that is supposed to be used in all the modern CI/CD automation workflows. What do I want from something that can stand the test of this fast-changing, rapid-changing environment? My first requirement really must be manageable. If I can't use it as part of my own management tool so far, if I need to add still something new, I just start adding technical debt to my solution that if I later want to change something, we'll need to do again. It needs to scale. Quite simple. It needs to be able to handle any scale, because it might be we might have a small solution right now, but if we're successful, we might be going big, and if it can't handle that, that would be a problem. I want my logging to have a very low impact. It needs to be adaptable. It needs to be changeable. It needs to be that without me having to actually change the code, be able to handle as many situations as possible that are likely to happen. And if it can't, I need to have a plan to migrate. I need to have something, even if my current solution is burning and crashing, I need to have a way out that does not require me to completely rewrite the entire code base of the last 2 years, because we don't have that time. So how do we do manageable and adaptable? It's the entire configuration thing that allows us to manage it from any kind of management platform and solution that we're currently using. If it's not currently implemented. It's extensible to be able to support that. Scalable. It does exactly no data management at all. You can write to any logging theme solution, platform, REST API, log file, SQL Server database, or whatever your personal preference is. But the module itself does not handle that part. It is completely Runspace-safe and thread-safe, so you can scale out as much as you want without having to handle any conflicts or what might happen from that. And it's asynchronous. Asynchronous was one of the most important features for me, because that means writing latency, like write to network share, write to service, does not slow down my main script. If I do synchronous logging, and I need to wait 2 seconds for the logging system to answer, let's just say your script performance will slightly suffer under that kind of environment. And migratable, it's extensible with plugins, and every single logging plugin can coexist at the same time. And what this means is you can do a switch over in production to a new system, load test the new system without losing your existing system. So you can, without any interruption, add, remove, replace your logging. Was there a question? All right, so how the hell does that look out? How the hell does the whole thing work? The architecture of the entire thing. You've got write PSF message. You execute it, it generates a message. And then that message goes into a black kitten box, and afterwards logs come out. All right. So the first thing, when you're using PowerShell framework, on module import, it starts a dedicated run space that executes the logging. So all the logs, all the processing happens in the background. I don't really know where the other run spaces come from. That's a VS Code kind of thing, and VS Code is, well, not exactly part of my personal pantheon. So I'm sure VS Code will do something with that. But there's a dedicated named run space for that. It only, of course, names it in PowerShell 5, because in PowerShell 3 and 4, there is no way to do so. And there's a dedicated feature in the PowerShell framework to have managed run spaces that are guaranteed to be unique. The thing is, if you've got a module that on import starts a second run space that executes in the background, imagine you scale out and import that module in 20 run spaces. And every single run space will add another one. You've got a squared number of run spaces, and they get in conflict with each other. So there is absolutely no way for them to parallelize, to spawn additional run spaces. I built an entire management frame around it to prevent that. Especially since I can't identify them by name on PowerShell 3 and 4. So I can't, like, is there already a run space with this name? I can't check that. Or can't rely on checking that, so not happening. OK, we can do asynchronous writing. And if we take a look at this message, there's a Runspace ID. So every single message can be tracked down back to what Runspace it comes from. So let's use push job to create 5 run spaces that will write 10 messages in an arbitrary order with some random delay in between. And let's see what happens. The first thing you can see, there's a tag parameter. You can tag message. It's an arbitrary choice of string. And you can later process the messages by that. You can apply rules to messages depending on the tag. And they keep coming and are written in the background. This is 100% thread safe. There is no way they can collide. They are written in the chronological order that the run spaces try to write it. The timestamp is generated before they're added to the queue, so even if there's some arbitrary delay, it's the original timestamp, the very second, microsecond, or tick that you call write piece of message. So let's take a look at the queue. When you write a message, there's a thread-safe queue, and you add messages, and it tries to process them. If you have too much delay in processing because you absolutely insist on having 20 different logging targets, you might hit the upper limit of the size. There's a size capacity to that is extensible if you need to, but at some point you've got that many messages, it might cause problems from memory of the process because you've got only 4 gigabytes. I have had that happen exactly once. And that was when I had a hung run space that was just hanging and blocking the entire logging. That was a configuration error on my part. But other than that, after a very short delay, it's gone again. And even if you close PowerShell, if a script ends, you end the process, it waits until the messages are flushed, so you will not lose any messages, except you have a terminal process crash. In that case, the final logging flushing will not happen. That's the one risk I can't mitigate. And the one risk that no asynchronous logging solution can mitigate. So with that, we're stuck with that. So what happens once the queue is being processed and the message happens, where do they go? And this is where the logging providers come in. Every single logging provider can be enabled or disabled by default. We only have the file system provider, which is the default debug log. There is also out of the box a provider for logging to Graylog and a provider for logging to a dedicated log file per script rather than a big one per user. Because this log in the logs folder here, there's like every single task, every single script, every single module you're executing under the given user will be in that folder. So figuring things out, tracking a certain script or task you're trying to execute in that log is not fun. It's just a backup in case you just didn't think to provide for logging. It's like something, it's there, you don't have to care about it, you don't have to configure it. It's just a backup, just in case. And so let's enable a dedicated log file provider. We use set PSF logging provider. You can do that interactively. You can do that by configuration. You can fully replace that command using configuration. You don't have to do this interactively in a script. We execute it with the name, select the file path parameter, which creates a new log file in the demo folder. And finally, we set it enabled true. That's all we really need to do. And if we now write a new message to the log, the log file was created. We have to wait for first entry. At the same time, it's also here. In this log, it was logged at the same time. Now if we go back to get PSF logging provider, you can detect that there are several columns that are kind of empty. You can completely configure or selectively pick which messages go to which provider. So we can have a full debug log to a debug log, but we can only say we only want one module to write to the log file and exclude all the others. So what we're doing is set PSF logging provider again, and again, this is available for configuration. We listed only my module is a legal module to log to this log file. And if you
wanted to log all the modules, would you just leave it
empty?
Without that parameter?
Yes. All right. One message from the module, the other message has no parameter. Write PSF message automatically picks up from which module the message originally came. So usually in a module, you don't have to specify the module name parameter. It's just for demo purposes right here, so I can demonstrate that aspect. And only the test2 message was written. The one that was without a module was not written to log file. But again, both of them were in the debug log. All right. So our overall architecture looks like this. We have multiple Runspaces. Multiple Runspaces can write to the same queue. The dispatcher script picks them up, applies filter, and sends them on to the logging provider that is enabled, and where the filter applies. It first checks for enabled, but that was kind of hard to get in that diagram. So if the provider is disabled, it does not check for the filters. And that is the one and truth and only truth. And well, no, this is still not all there is to it. I'm not going to bore you with the following details, but I know I'm going to be nailed down by somebody who discovers them. We have quite a bit more. We can apply complete message transformation rules. We can change the target objects. We can apply policies. And we can even chain script block events to messages if we really want to. OK. Now, logging is nice, but multilingual requirements are less nice. I mean, it's all right if somebody asks me to make a module multilingual in the help, create like German help file and an English help file. I can deal with that. But now I've got this customer that asks me, yeah, Fred, that's all nice, but most of our admins are Germans, not all of them, so we need to have English support. But we want localized messages. They use dash verbose. We want to have it nice German on screen. And by the way, while we're at it, parameter validation, we want a German error message even for custom things. We don't want any custom things. We don't want to throw some English text. They need German input. Yeah, thank you. At the same time, who of you has ever had to deal with all these nice, friendly Windows command line applications we administrators have to deal with, something like, NSLOOKUP, and they all have localized text, which is all nice if you're Americans and all your online documentations are in English. But let me tell you, in Germany, that is not quite as much fun. Thank you. OK. So the first thing is, if we are going to go multilingual, we need language files for each language that we're supporting, which is basically a hash table with keys and values that are part of that. And of course, we also have an, English version. The command we use to read them is import PSF localized string. It needs a path, it needs the module it is assigned to, and the language it's appropriate. We always load all languages, not just the current one. And since this is also module bound, I'll just set the default module name appropriately. And here's the thing. By default, it picks up the system default language. But the user can use the configuration system to change the language to whatever he prefers. If there is no language file, language data for his language, it will default back to English. If there's not English, it will default back to something random else. You can do partial translations. So you can have like a colleague that's helpfully translating your module to Spanish, and he only has time in 2 weeks. In the meantime, the new features will just get English messages. All right. So let's pet some kittens. Change it to German. Get Jeffrey to do something. And if we now look into the logs, both messages are in German. The in-memory log calculates the language when you request it and stores the actual language key. So if you at a later time decide to switch the language to something reasonable, and please forgive us Germans for our language, it's back to the language you prefer. But what's happened in the logs now? Both are written in English, even the one that I was originally executing in German. The thing is, the log file has completely different language settings. By default, it's always English. And no matter what language the user prefers to see on screen, and no matter what your environment of your servers, the logs will always be in English or in another language you chose to deploy by configuration. Which is hidden in the following configuration key. All right. Let's go extend the logging. The keyword here really are logging providers. That's the term that's used throughout the entire module. And what they really are is a custom package of pieces of logic and configuration settings and some other elements that make up all the user experience of the thing. And really, the main part is, think of it, it's like event-driven, and you need to provide script blocks for certain events. There is one big gotcha, and it's important enough to me that I point it out right here, right now. All resources in the logging scope, all logging providers are executed in the same scope. So you have the potential conflict to override variables if you use generic variables. If you scope every variable and every function, prefix it with the provider name, you're on the safe side. That's basically the policy. That's the one gotcha. There will be an updated version that solves that problem, but it's not quite trivial to make not break anything else because it's a highly integrated solution. There will be an update in coming months. I can't promise you when exactly. So how does the workflow operate? You have one script block at a begin event that happens before the execution. This happens when you try to enable the logging provider. It executes that once. If you need any helper functions for your logic, that's where to place them. Then it executes the start event, message event, error event, end event in an infinite circle, trying to process any messages. And finally, if you terminate it, disable it, or PowerShell is closing at the end, it executes finally, where you can remove sessions. Why is there this one especially green? This is the only thing you need to do. You can ignore every single other event. If you've got a SQLite log and a log file locally, and all you want to do is like just dump the messages, just add a script log for message and ignore everything else. Give it a name, give it that piece, and you're done. So let's go back. By the way, this was the last relevant slide except for the outro. We're finally done with PowerPoint. Let's create a logging provider to event log. Don't have one yet. And it can't be that complicated, can it? So all we do is we run event log in the message event. That is the one mandatory. And all we're doing is use write event log in the PowerShell log, type information, category 1, event ID 1000. I just arbitrarily decided on something. You could also add installation logic and create your own source for event log. And finally, we just grab the message, do a format list on it, convert it to string, and add that as content. Yes?
Can you write to the security event log with this? Because I've had issues.
You can do that if the account has write permission to the security event log and you're executing it with elevation.
Okay.
And at the same time, you could also, of course, include a public key certificate on the machine and encrypt it using the CMS module, and thus do encrypted logging. It doesn't do that by default, but I might be adding that actually as a permanent feature that can be enabled by configuration. So it would need a certificate deployment, obviously. And finally, we need to set it as enabled. By default, it is not enabled unless you use that parameter. With that done, let's just write some arbitrary piece of text and use getWin event to retrieve it. Everybody in the room knows what the difference is between getWin event and getEventLog? For those who have trouble, who don't know, getEventLog downloads the entire log and does client-side execution. But it has more convenient parameters, which is one of the persistent problems I see with that in the field. All right, and with that, we just now have the entire message from the write PSF message command in event log. Now, we also can register an error event that is executed when an exception is written, and it receives the error object, so we can properly serialize it and maintain the original data. So what we're doing here is we are creating an event log entry, and the PowerShell framework has a command called convert to PSF CLI XML, which is basically similar to export CLI XML, only it doesn't write something to the disk, it writes something to memory as a string, and it archives it, it compresses it. XML is not the storage-friendliest way of formatting text. And event logs have a fairly strict limit how large a message you can write to it. So using non-compressed CLI XML data would not work well. With this, we can easily compress it. Disadvantage, we will have base 64 string in the event logs, so filtering something event log side based on error content is not possible. We need to retrieve all messages and convert them locally before we can start processing error records that way. So, registered. Let's disable the other one. And now we are just going to execute write PSF message, level warning, failed, and important pass through the error record. Otherwise, it won't have an error to serialize. And if we now retrieve the event log entry and convert from PSF CLI XML, we can revert it to the original error object. And get all the data, exception type, and meta information behind it. It's a converted type because it's not the original error record, it's a PSF error record, because several exception types that we see have problems that you start serializing entire assembly information that can blow up your debug object by several gigabytes and permanently hang your loggings. That was the one error I mentioned about not handling things quite right. And the event log kind of complains if you try to push several gigabytes of data into it. Picky thing. All right. And finally, we have warnings, and writing that as information entry in event log is a bit nasty. So we can, of course, differentiate between various message levels, vary how exactly we want to write it to event log, and make it more easily filterable and monitorable by our theme solution. And disable the previous one, write a warning, and it'll turn up just fine. The message is not displayed here. We need to expand the message in order to see that. All right. Finally, I just created a dummy logging provider for the content, just a SQLite variation, and it handles all the script logs events. If you want to look that up later in the materials, the entire presentation materials will be found on GitHub. I'll be releasing that probably tonight. And paste a link in the Slack channel so you can look at the various details. The first region is the actual logging execution. We can add logic that should be executed when you register it. We can also add a few other pieces of information that were not covered in the high-level information. Specifically, set PSF logging provider we were able to specify the log file path of log file. That parameter does not really make sense when we're looking at the event log provider. So what we can do is provide script logs that are consumed by dynamic parameters to dynamically generate the configuration settings as parameter in case we have got users that want to interactively control it on the console, or we want to configure it by command rather than configuration. So we can do both sides of it. And there are also configuration script settings that allow us to define our configuration data or settings as configuration that can be consumed by JSON or whatever, provided by JSON or other configuration input format that we prefer. That would be basically the full template for that. All right, we are literally at the end of the main narrative I had prepared. I've got lots of more details in case nobody has any questions. Any questions so far about the entire thing? All right, in that case, something I mentioned earlier, if I use -debug by now, and we still have 1 minute, so that's enough. Basically, there's a parameter called breakpoint, and if you use write PSF message within a command, it will not interrupt you on -debug unless you specify the breakpoint parameter. So if we try this out in action, either it's empty. With verbose, we only get the first message. And with debug, we are only interrupted on the third one. The second one will just pass through. You can see the number here on the left side. That's the line number it was written from in order to be more easily able to add breakpoints. And they were even written on verbose messages or in host messages. All right, thank you.